Yes. Okay. So today we're going to go over angle relationships. So different types of pairs of angles. So the first one I have in this nice big chart here is adjacent angles. Okay, so these are two angles that lie in the same plane. Okay, so we're still working with those planes. Two angles that lie in the same plane and have a common vertex, a common side, and no common interior points. Okay, so an example of adjacent angles. I'm going to draw some nice pictures here today. Okay, so if I have this angle, right? An angle adjacent to that would be if I have another ray. So it's sharing that common vertex. Okay, I'll just call it vertex B. They share that vertex. Okay, and they share one of those rays. Okay, so they would share this middle ray right here. So if I label my angles, I'm just going to label them 1 and 2 because I like to use numbers to label my angles. Just makes it a little easier. I could say angle 1 is adjacent to angle 2. Okay, so they share that ray and they share that vertex point. A non-example of this, if I had an angle here and say another angle floating over here in the same plane. Okay, so those are two different angles, right? But they don't share a common vertex, so your vertices are different. Okay, this one we can label A and B, different vertices, and they don't share that common ray. Make sense? All right. In the middle section there, we have a linear pair. Okay? So these are adjacent angles whose non-common sides form opposite rays, which means, again, what we did Friday, we have opposite rays to form a line. Okay, so they're adjacent angles that form a line. Okay? So if I draw a picture of this, I'm going to draw a line first. And then I want to draw a ray coming off of that line. Okay, and I'm going to label my angles again. So I have angle 1 and angle 2. You can see they're adjacent, so they share this vertex right here. Now if I have two angles that are adjacent and form a line, those angles are going to be supplementary. Okay, which means they're going to add to be 180. Okay, so if you have two angles that form a straight line, you can add them both together and they should equal 180. So if I take the measure of angle 1 plus the measure of angle 2, they should equal 180 degrees. And for this, they have to be adjacent. So to be a linear pair, they have to share that vertex and that side. So a non-example of this, again, if I have two angles, so I'll have one here, and I'll make another one down here. I'm going to label this angle as 50 degrees and this angle as 130 degrees. Now these two angles, if you were to add them together, would equal 180. Okay? But they're still not considered a linear pair. So if you have two angles that add to 180, it's not always a linear pair. Okay? Questions on that one? All right. Then next we have vertical angles. Okay, these are two non-adjacent angles formed by intersecting lines. Okay, so when you have vertical angles, you're usually going to see this X shape. Okay, so you want to look for that X shape. Now, vertical angles are always going to be congruent to each other. Okay, I'm going to use that congruent symbol if you forgot what it means. It means congruent, they have the same measure. Okay, so vertical angles are always congruent. So for my example, I'm going to draw in two lines. There's one. And we want them intersecting. So there's two. You can see it makes that X shape. So now I'm just going to label each of these angles. You can see it makes up 4 different angles there. We have 1, 2, 3, and 4. Now vertical angles are the angles across from each other. Okay, so I could say the measure of angle 1 is equal to the measure of angle 3. Okay, so 1 and 3 are going to be the same. 1 and 3 are congruent to each other. They're across from each other. Same thing with 2 and 4. Okay, so the measure of angle 2 will be equal to the measure of angle 4. Okay, so angles across from each other, those are your vertical angles. And they're always congruent to each other. So if you're setting up an equation, say this angle right here, number 2, was like 3x. Okay, and the angle across from it said 40. Okay, you can set 2x equal to 40 and then solve for that variable. Okay, so setting those two equal to each other to solve or find that angle. A non-example. So I'm going to draw in my angle this way. Okay, I'm going to make it look like I don't have a straight line here. Okay, so if I had a straight line, it'd go down this way, so I kind of did it off to the left there. Same thing here. I'm going to go this way. So if I look at this angle here and this angle here, okay, those angles appear to be across from each other, right? But they're not made up by two intersecting lines, so they're not considered vertical angles. Okay, so just because an angle is across from doesn't always mean it's vertical or equal to each other. Okay, it has to be made by two intersecting lines. So they have to be a straight line through. So in this case, I can write the measure of angle 1 does not equal the measure of angle 2. Okay, so those two are not equal. They're not vertical angles. Questions? Are these vocabulary words making kind of sense here? Play a game? You asked if you can play a game?
Math.
Oh, math game.
Yeah.
No, you're not playing it. Alright, so on the next page we have complementary angles and supplementary angles. So complementary angles are two angles with a sum of 90 degrees. Okay, now for this one I'm going to show you two different examples. So I'm going to split this box in half. So you can just draw a line, it doesn't have to be wavy, I just drew it wavy. So we can have our two angles. Okay, I'm just going to draw a 90-degree angle first. Right, with that box in the corner. I'm going to draw a ray through that angle. So now I have two adjacent angles, okay? I'm going to label them 1 and 2. So if I took the measure of angle 1 and added the measure of angle 2, it would give me 90 degrees. Okay, so those would be complements of each other. Okay, so they add to 90 degrees. And you can see that by that box in the corner of that original first angle we drew in, right? Now the second type is if I just had an angle here. Okay, I'm going to label that angle as 30 degrees. And if I had another one over here, and I label that one as 60 degrees, these would also be complementary angles. So with complementary angles, you don't have to be adjacent. Okay? So it doesn't have to be adjacent to be a complement of each other. Just two angles that add to 90 degrees are complementary. For supplementary angles, these are two angles with a sum of 180 degrees. Okay, so again, I'm going to have two examples here. So for supplementary angles, they could be adjacent. So a line is 180 degrees. And again, I'm going to draw a ray coming off of that line. Okay, so I split it into two angles. I can label each angle 3 and 4. So if I took the measure of angle 3 and added on the measure of angle 4, it would give me 180 degrees. So those are supplementary angles. Okay, they both add to be 180. Now, just like with complementary angles, I could have them split and floating off next to each other, okay? So they don't need to share that vertex or ray. So if I have this angle over here, okay, we'll call that 80 degrees. And then this angle over here, call that 100. Those would also be supplementary angles, so they don't have to share that side. Okay, so complementary, supplementary don't need to share a side. Just two separate angles that add to be 90 or add to be 180. Okay? Easy way to tell the difference between complementary and supplementary. C is first in the alphabet, 90 comes before 180. Okay? So if you get confused with complementary and supplementary and you don't know which is which, C comes first, 90 comes before 180. Okay? Easy way to remember. If you forget. Questions before I move on? Alright, so in this first question here, what is the difference between supplementary angles and a linear pair? I want you to discuss this question in your group. So if you need to look back at what a linear pair is, look back on the front. Okay, then look to supplementary angles on the next page. And then talk about what is the difference between the two.
They have to be on the same wavelength.
Once you guys agree on what the difference is, write it out on that line. All right, what are some of the things that you wrote down? Anybody want to share? Go ahead.
Supplementary angles don't have to be.
Thank you. Okay, so supplementary angles don't have to be adjacent. Okay, a linear pair has to be adjacent, supplementary don't. Number 2, true or false? Supplementary angles always form a linear pair. Supplementary angles always form a linear pair. Is that true or false? Anybody want to give me a guess?
False. Yes.
False. Okay, so a linear pair is always a supplementary angle, but a supplementary angles aren't always linear pairs. Okay, that goes back to the supplementary angles don't have to be adjacent piece from question 1. All right, so looking at our next example here, we want to name the supplement and complement of each angle. Supplement meaning what makes it add to 180. Complement meaning what makes it add to 90. Okay, so if I'm given an angle of 60 degrees and I want to find the supplement of that angle, I want the second angle that makes them added together to be 180. Okay, so in order to do that, I'm just going to take 180 and subtract 60, and yes, it's 120. Okay, then the complement of that angle, I would take 90 minus the angle I was given. Okay, so the complement to 60 degrees would be 30. The supplement to 60 degrees would be 120. Okay, looking at number 4 is 45 degrees. Okay, finding the supplement first. Supplement is 135. Complement is 45. Now with number 5, it says n degrees. So that means it could be any degree amount. So what you want to do with this is the same process you were just doing. So how did I find the supplement when I did numbers 3 and 4? What did I do? You subtracted. Okay, so you're going to take your total angle degree, which is 180. Okay, and you're going to subtract your angle measure. So the supplement to n degrees would be 180 minus n. And then the complement, yes, would be at 90 minus n. Does that make sense? Supplement and complement. All right, so next I want to look at perpendicular lines. Okay, so perpendicular lines intersect to form 4 right angles. Form 4 right angles. So in your picture over here, if these are perpendicular, this angle right here would be 90, 90, 90, and 90. Okay, so it forms those 4 right angles if you have perpendicular lines. Okay, so perpendicular lines also intersect to form congruent, adjacent, angles. Okay, so if you look, if I have perpendicular lines here, those two angles would be congruent because they'd both be 90, and they would be next to each other. Same thing if you did it here, or the other way as well. Okay, so they form those congruent adjacent angles. Okay, so segments and rays can be perpendicular to lines or other segments or rays. Okay, so you don't always need them to be lines. So they could be two rays are perpendicular, okay, or two segments are perpendicular. Doesn't always have to be two lines are perpendicular. Okay, so the right angle symbol indicates lines are perpendicular. Okay, so we use this upside down T to show that lines are perpendicular to each other. Okay, that's what I used up here. I didn't want to write perpendicular. So if you see that upside down T in any type of problem you have, that means those lines or segments or rays are perpendicular to each other. And the angle measure would be 90 degrees then. Okay. It's kind of similar to your box in your corner, okay, of your right triangle. You can kind of refer back to that. Questions about perpendicular lines? All right, so a few examples here. We want to find x and y so that line PR is perpendicular to line SQ. Okay? Line PR and line SQ. We want them to be perpendicular to each other. So if line PR is perpendicular to line SQ, then the measure of angle STR would be what? 90. And the measure of angle PTQ would also equal 90. Okay, so we want to find x and y then. So if this is 90, I'm going to label it with that square in the corner. So to set up an equation to solve for, I'll solve for y first, just because I used that one first. I could take that 4y minus 2 and set it equal to 90 because I want it to equal 90 degrees. Now to solve for y, you add 2. So I have 4y equals 92. Divide by 4. And y will be equal to 23. Okay, not so bad. I also need to find x. And I know angle STR is also 90 degrees. Now I have two adjacent angles here. Okay, two angles that are next to each other. They form that right angle in total. So how could I set this up to solve for x? Yes, I want to add them together and set them equal to 90. So I'll take 2x plus 5x plus 6 and set that equal to 90. Because I want both of those together to add to 90 degrees. So I have 7x plus 6 equals 90. Minus 6. So I have 7x equals 84. Divide by 7. And x is 12. What? I have one more example. Questions on that one that I just did though? Alright, example 2, you don't even need the picture. Okay, example 2. Can you go over there, please? Okay, go over there. Example 2, we want to find x if the measure of angle D is equal to 3x minus 12. And it's telling us D is a right angle. What does that mean? D has to equal 90 degrees, right? So since I'm given this equation for angle D, I can just set 3x minus 12 equal to 90. I'll add 12. So I have 3x is equal to 102. Divide by 3. And x is equal to 34. Questions? So on your yellow sheet assignment,